Okay, so I hope you enjoyed the video on significant figures. We're going to talk about that in the next video. But before we get to that, we're going to talk about our accuracy and precision. This is not in the textbook, but it is going to be important for you to know the difference between the two. And yes, there is a difference as well. Our accuracy is going to be the closeness of a measurement to the true value. And this is going to be a long definition, so I'll try to get this on the line too. Basically, our accuracy depends on the equipment that we are using. So if you have very poor or cheap equipment that you're using, then your data is going to be less accurate. And basically this is saying if we have better equipment, if you're using more accurate scales, then you're going to get more accurate results, which makes sense. If you're using a $20 scale versus something like in the chemical lab that we have these $1,000 scales, you're obviously going to get better results and more accurate results from that as well. So the better equipment you have, it's going to equal better accuracy. For our precision, it's going to refer to the reproducibility of the measurement that we have. And this precision is going to depend on the ability of the person running the test. So in the beginning, we might not have very precise results because you need more experience to get better precision. But by the end of the year, we should be both accurate and precise. So all this is saying, the more experience that you get, the more precise you will be. I'll give you a visual representation for this too. For people who play golf or have played darts before, if you're able to hit the same shot 3 times in a row in golf, if you're aiming at the pin, then you're going to be very precise. You might not be accurate because you're trying to get it into the center where the pin is, but if you're able to reproduce those shots, you're going to be very precise with your swing, which is different versus accuracy. You might be able to hit the ball at the pin, but it's going to be different location every single time. Now, what we're trying to get to and what our goal is to be both accurate and precise. You're able to reproduce the results and you're getting very good accuracy as well to the true value that we're looking for. And there are ways to measure our accuracy and precision. One is called percent accuracy, which is on the back of your periodic table. And there's also one that's going to be our percent precision. And we'll talk about those. We're going to have our lab experiment. We'll do the math for these as well, so don't worry about the formulas just yet. Ideally, you want to be less than 5% for both, but depending on what we're measuring, that can vary. So we'll go through an example of these for our lab experiment too. Maybe not this first lab, but we will in the future. Let's get rid of this. Okay, that's good to know. There are going to be uncertainty in measurements too, and 2 important things to remember that we're going to look at is not all equipment is really accurate. Like we said, if you have a $20 scale versus a $1,000 scale, you better hope that you're getting more bang for your buck out of that $1,000 scale. And the last one, not all measurements need to be accurate and precise.